real-world examples. Learning basics of ad hoc. All right, let's move on to some more useful ad hoc commands in the form of package management. Now, Ansible supports both yum and apt for Ubuntu-based systems or Debian-based systems. In this example, we're going to be using yum because our lab and our testing environment is going to be running CentOS. But you would substitute the apt command instead of the yum command if you were on a Debian-based platform. So for this example, we're going to install the latest version of the Apache web server across all of our web server hosts. Now, we can't necessarily call them web servers without a web server installed. So this should take care of it for us. Let's walk through the command. We're going to be running Ansible against the web servers group inside of our inventory file. We're going to be passing the yum module, or the yum command, with the action of httpd, which is the name of the Apache web server package, and its state should be the latest. So let's see what happens. Now in the background, Ansible will be going to each one of these servers and running yum install httpd-y. Now if we were to run this again and there was a newer version of Apache, it would simply update it for us because we're passing state equals latest. So let's run it again and see what happens. All right, so this tells us that all of the Apache packages on all of the systems are not only installed, but they're of the latest date, or they are the latest version available to that distribution. Excellent. This is a very simple way to sort of automate your package management in kind of an ad hoc fashion. Now, the sort of proper long-term way would be to manage this with playbooks, but we won't get into that until Chapter 3. Okay, moving on. Now that we've installed the Apache web server and we've ensured that it's the latest version, we want to make sure that it is starting and running. So, along with the package management modules, such as apt or yum, there's also what's called the service module. Now, this is meant for sort of quick and dirty interaction with system services. Now that we've installed our Apache web server on all of our remote hosts, we're going to be using the service management modules, like the service module, to start and stop system services. Now, this is a very quick and dirty way to start or stop services on a bunch of remote hosts. Again, like the package management module via yum or apt, it's not the most ideal long-term way to manage hosts and keep them in a desired state. But this is a very quick and easy way to get the job done. So let's give it a try. So here's the command that we're going to be running. And again, let's note the format of this command. We're going to be running Ansible against the web servers group inside of our inventory. We're going to be calling the service module to do the heavy lifting for us. And the action that we're going to take is that we want the service httpd or Apache to be in a state of started. Let's make these real web servers. Okay, so we got quite a bit of information back. Probably a lot. If you want to dive through sort of the details, it'll tell you that the state has changed. Change true. Here's kind of the important bits here. This is just taking from one of the hosts. But changed is true. Failed is false, which is good. No one likes failure. The package name is httpd, and the state is started. All right. So what we could probably do, building on what we just learned, is let's use the simple command module and let's run systemctl status httpd which will tell us the status of the Apache web server on all the hosts. All right, we have all green. And we see, some diagnostic information that you would expect from systemd. And we see that our web servers are running. Excellent. Okay, now we've got the latest version of the Apache web server installed via the yum service module in an ad hoc fashion. Again, if you're using a Debian-based system, you would use apt instead of yum. After that, we used the service module to ensure that the latest version was running, then started our service. Now it's time to put some content on our web servers. So, let's take a look at what they look like. Here at the top, we've got the latest version of Apache running on all of our servers. But this is just a generic welcome page. This is what you would expect when you first install the Apache web server. But let's use Ansible to automatically put some content down on these remote web servers. For this, we're going to be using the script command as part of the ad hoc series of Ansible tools. We're going to be copying a script that we created called create_content.sh. Now, if you remember back in Chapter 1, we did a very brief proof of concept using the Ansible script module, except in a playbook form, to copy the heartbleed.py script to all of our servers and then check to see if they were vulnerable to the Heartbleed exploit. This is very similar to that. The only difference is that we're going to be copying a shell script to each one of the hosts, and then the script module in Ansible is going to be executing that script. Let's take a look at our script first to see what it does. So we have a content create content.sh. This is the script that we're going to be executing remotely across all of our web servers. Now, all it does is a very generic cat EOF with this text here. We're creating a skeleton website content that should create a page that simply says, created by Ansible shell ad hoc module. Excellent. So let's run this. Again, let's walk through the commands. We're going to be running Ansible against the web servers inventory group. We're going to be passing the module script with the action of the name of our script that we just viewed, create_content.sh. So let's run it and see what happens. Okay, we have a similar response as our other commands. It tells us that we have success. Excellent. Now let's take a look at our web servers again and see if the content changed. We're going to go ahead and refresh the first host. All right, look at that. Now we've got new web content automatically deployed with one command by Ansible. Outstanding. Now, these are just simple examples. The goal of this exercise is to show you the method that you can then expand upon for your own uses and get things done quicker and easier with Ansible. But let's not stop there. Let's do some file management. So let's say that we already had an index.html that we wanted to display, and the new one that we created prior was just to have kind of a placeholder there. But let's say we had a very fancy website already prepared that wanted to just deploy on many servers at once. So Ansible, in an ad hoc fashion, has a copy module, which does just that. It will let you copy data locally to a certain destination on each respective host that you're administrating. Okay, we've copied some web server content out to all of our servers via the script module. But let's say we have a more fancy website that we want to deploy, and we have the actual website content already created that we want to push out and update the web server content with. We have a index.html file here. As you can see, it's extremely fancy. It's actually the same as the other file with just some different content here, different sentence. We're going to replace the current web content on all of our 4 web servers with this index.html file. Now again, this is a very simple example of the copy module. And it's really meant as sort of a construct for you to build on, to do things that are useful for you, to save you time. If bundled in a proper playbook, you could have many layers of content distribution being pushed out by Ansible to keep your battery of web servers up to date with the latest content. And all of this could even be automated as well. There's a lot of options to this, and it's really open-ended what you can do. But for these intended purposes, we're just going to keep things very simple. So let's walk through the command that we're going to run. Again, we're going to run Ansible against the web servers group inside of our inventory. We're going to be specifying the module copy because we're going to be doing a copy operation. And the options to copy are going to be our source file, which is index.html, which we just looked at. And then the destination is going to be the Apache web root index.html, which should overwrite the previous content that we just created. So let's run it and get started. Okay, so we have a similar response back from Ansible. Gives us a checksum. Outstanding. So let's see if our web server content has changed. All right, Ansible updated. The last part that I want to cover for this chapter is Ansible Facts. Now, Ansible Facts are bits of information about your running system, about the hardware, and all types of sort of system and operating system level metadata that Ansible can gather. Now, by default, Ansible does facts collection when you run it against hosts, but you could turn that off. As we mentioned in the first chapter, there's some occasions where you need to run Ansible on systems or devices that don't have Python installed. And in some cases, they may not have SSH installed either. So, turning on or off facts is going to be useful in those scenarios. But for the most part, what we want to focus on here for facts is that all of the future intelligence and automation that we can build into Ansible can be harnessed by the values that we receive back from fact discovery. Facts only require Python and SSH, and pretty much any value that you can get returned back from the facts collection, you can then perform an automation against those values. We'll get into this more in the next chapter when we go into inventories and playbooks. But for now, I just want to show you how to collect the facts. So, the syntax is very simple. We're running Ansible against our web servers inventory group. And we're simply just passing the -m setup. So let's see what we get back. As you see, there's an enormous amount of information that we're getting back from the facts collection. Everything is in a JSON format, so it's easy to parse and write additional tooling that can harness the values if you like. But this is overwhelming, so let's step through just some of this. Okay, so we're going to run the same command, but instead, let's pipe it somewhere so we can inspect it. So let's pipe it to temp facts.json. Okay. All right. So let's take a look at facts.json and see what we have. So, anything you could normally expect, such as the IP address, VM Linux information, grub information, date and time, interface information, disk information. When you look through these values and you look at all of the information that Ansible Facts collects, what you should keep in mind is every one of these values can be queried to then run and develop further automation against your systems. For example, if we wanted to have a very quick Ansible playbook that looked at disk space used out of total and then reported back how many of these machines were over 70% disk usage, well, that would be fairly easy. That's just a small example of some of the things you can do with the data harness by Ansible Facts. I'm going to give you a practical example of how people have used the Ansible Facts to create some very useful visualization data about the state of the running systems. So Ansible CMDB is a project on GitHub which takes the Ansible Facts collection and generates very useful visualizations out of it, so either in HTML, CSV, SQL, whatever you like. Now, looking at this example here on the site, this entire page was generated by a simple Ansible Facts collection. This gives you sort of an idea of some of the things you can do with Ansible Facts.